Good morning, students. Welcome to your Data Communication and Computer Network class for 4th Sem IT. In the previous video, I have discussed about asynchronous and synchronous data transmission. While transmitting the data, there may occur some error, and in this video, I will discuss about different error detection technique and a error detection technique known as single parity check. After completion of this video, student will know about different types of error, error detection techniques, and single parity check. So let's start. First of all, what is error? Error means when data is transmitted from one device to another device, the system doesn't guarantee whether the data received by the device is identical to the data transmitted by another device. Means there may be some changes in the data sent by the sender device in the data of the receiving device. An error is a situation when the message received at the receiver end is not identical to the message sent by the sender. Okay, means there may some changes in the data. And there are different type of error. So mainly error are of two type. First is single parity and burst error. Single bit error. First is single bit error and second is burst error. So error can be classified into two categories, single bit error and burst error. So single bit error means the only one bit of a given data unit is changed, maybe from 0 to 1 or from 1 to 0. So only one bit of a given data unit is changed. That is known as single bit. Maybe 1 is changed to 0 or 0 is changed to 1. So in this example here the data is 0 0 0 0 1 0 1 0. Okay, but at the this is the receiver end, but the sender is sending 0 0 0 0 0 0 1 0. Here the fourth 0 is changed to 1. Okay, so this is single bit error. Here the 0 is changed to 1. Then the next is burst error. The two or more bits are changed from 0 to 1 or from 1 to 0 is known as burst error. The burst error is determined from the first corrupted bit to the last corrupted bit. So let us see the example. The data is 0 0 0 0 0 1 0 0 0 0 0 0 0 1 0. Here the data is changed 0 to 1, again 0 to 1, then after here 0 to 1 means thus 1, 2, 3, 4, 5. This 5 bit have changed. So the length of the burst error is 5. The duration of noise in burst error is more than the duration of noise in single bit. Burst error are most likely to occur in serial transmission. The number of affected bits depend on the duration of the noise and data rate. Means when a single bit is changed, that is known as single bit error. When more than two or more bits are changed, that is known as burst error. And the next is error detection codes. Error detection techniques are implemented either in data link layer or in transport layer of OSI model. Whenever a message is transmitted, it may get scrambled by noise or data may get corrupted. Means the data is affected by noise or the data can corrupted. And to avoid this, we use different error detecting codes, which are an additional data added to the digital message to help us to detect if any error has occurred during the transmission of the message. Means the error detecting codes are the some extra bits which added to the original bit to detect whether there is an error or not. And the basic approach used for error detection is the redundancy bit. Okay, redundancy bit where additional bits are added to facilitate detection of error. Means we add some extra bit that is known as redundancy bit to check there is error or not. And some popular error detection technique are single parity check, two-dimensional parity check, then checksum and cyclic redundancy check (CRC). And in this video, I will discuss about single parity check. So, single parity checking is the simple mechanism and inexpensive to detect the error. In this technique, a redundant bit is also known as parity bit, which is appended at the end of the data unit so that the number of oneness become even. Therefore, the total number of transmitted bit would be 9 bit. Means if the data is of 8 bit, then an extra parity bit is added and the transmitted bits are 9 bit. And in even parity, we check the number of ones. If the number of ones bit is odd, then parity bit will be 1. Means if number of 1 is odd, we add extra 1. That is the parity bit to make it even. Okay, means it is even parity. And if the number of 1 is even, then the parity bit will be 0. 0 is appended at the end of the data unit. At the receiving end, the parity bit is calculated from the received data bit and compared with the received parity bit. Okay, means at the receiver side, the parity bit is again calculated from the data and checked with the actual parity bit. Okay, this technique generates the total number of oneness even, so it is known as even parity checking. Means in even parity checking, it checks the number of 1. If the number of 1 is odd, then parity bit will be 1. If the number of 1 is even, then the parity bit will be 0. So here is an example. Sender sending the data 101111. Okay. Then compute parity bit. Here the number of 1 is 1, 1, then 4, 1, here 5. Means number of 1 is 5. Means odd number of 1. Then for odd number, we add a extra 1 to make it even. So the parity bit will be 1. Okay. Then the data will be transmitted. Here at the receiver side, it again compute the parity bit. Here the 1 is number of 1 will be again 5 and it will generate the parity bit 1. Then if the parity bit 1 means even number of 1, if the number of 1 is even, then accept the data. If the number of 1 is not even, then reject the data. Okay. If the number of 1 is even, then accept the data. And if the number of 1 is not even, then reject the data. This is all about your single parity check. So now let us consider another example. Here the data units are here 1111 then 000. means here number of 1 is 4, means even number of 1, then the parity bit will be 0. Okay, and here in this case in second data unit the number of 1 is again 1 2 3 4, means even number of 1. So for even number of 1 the parity bit will be 0. Here the number of 1 is 1, 2, 3, 4, 5, 6, 7. Means odd number of 1. For odd number of 1, the parity bit will be 1 to make the one number of 1 is even. Okay. This way we can generate single parity bit. But the main drawback of single parity checking is it can only detect the single bit error. And single bit error are very rare. If two bits are interchanged, then it cannot be detected error. So in this case here, the data is 00000010, means here number of 1 is 1, means odd number of 1. So the parity bit will be 1, means the parity bit will be 1. And if there will be a changes, the data is corrupted here, the data is changed, 0 bit is changed to 0 to 1. And again this bit is also changed 0 to 1. So the number of ones become 3 ones, and also the parity bit is 1. So here we cannot detect the changes over here. So more than one bit, if more than one bit is changes, the single parity bit will not work for this. Okay, so this is all about your single bit parity checking. In next class, we will discuss about two-dimensional parity check and checksum. Thank you.